Hello everyone. This video is on section 10.4 part 1 titled Understanding the Properties of Logarithms. So in this video I'm going to be going over a version of the Knewton Alta assignment for section 10.4 part 1. Now please understand that the questions that I see in this video may not be the same questions that you see when you work on the assignment yourself. But the objectives are the same, the types of questions are, should be similar. So I'm hoping that watching me go over several questions here will help you in some way when you work on the assignment on your own. Alright, so here's the assignment page. You will not see the words preview of. You're just going to see the title of the assignment. Then you have the mastery bar, which tells you how far along you've gotten in the assignment. And then you have the objectives. And it looks like there are 2 objectives for this particular assignment. And then whatever the current objective is, you have a question beneath it related to that objective. And at the bottom of every question, you should be seeing a feedback button where you can send feedback to Knewton if you wish. You will not see the instructor cheat button. Right, that will not be there. But you will see a more instruction button, which you can click on and see further reading material, maybe some videos that are related to the current objective, and hopefully those help. Alright, so this first question is on the objective, use the product, quotient, and power properties of logarithms. Alright, so before I actually get into this particular question, I would like to discuss, these properties. I'll write those out. Alright, so I'm going to get into these properties of logarithms. I'm just going to state them and then just keep referring back to them when we need them for certain questions. Alright. So the first of these is the product property. Alright, the product property for logarithms. So it's the following. If you're taking the logarithm, say base b, right, with a little b down here, if you're taking the logarithm of a product, say, a times b, x, let's do x times y. Let's do x times y. So inside the logarithm is a product, right, a multiplication with multiple factors. Well, this will be equivalent to the log of one factor plus the log of the other factor. So you can take the log of a product and write it as the sum of logarithms. This is going to be equivalent to the logarithm base b of one factor, right, x, plus the log base b of the other factor y, right? And if there was a third factor, then you'd write plus, the log of that third factor. It doesn't have to be just 2 factors, but if you have a product inside your logarithm, you can split it up and take the sum of the log of each factor. Right. And vice versa. If you see the sum of 2 logarithms with the same base, you can put them together, make it a single logarithm, and the argument of the new log will just be the product of the arguments of the other logs. All right. That's the product rule, the product property. All right, then we have what they're calling the quotient property. So this is where you have the logarithm. You're finding the log base b of a quotient or a fraction. So say x divided by y. Alright. So the argument, the inside of the logarithm, is a single fraction. Well, you can split this up as well. You can rewrite this as an equivalent statement. This would be equivalent to the logarithm of the numerator. So the log base b of the numerator, which I called x, then minus, right, it's a difference, minus the logarithm base b of the denominator y. Right, so the logarithm of a fraction, or a quotient, is the difference between the logarithm of the numerator and the logarithm of the denominator, right? And it's got to come in that order. And, this is an equal sign, so it goes in both directions. If you ever see the difference of two logarithms with the same base, you can put it together to make a single logarithm of a fraction, where the numerator of this new argument is the argument of the first logarithm, and the denominator of this new argument is the argument of the second logarithm. And then finally, for this particular objective, there are more properties we'll get into, but for this particular objective, the objective is use the product, quotient, and power properties. So here's the power property. Alright, so this is where you have the logarithm, base b, whatever the base is, of some expression raised to a single power. And I'll use p for power. Now you got to be careful with this one. You can't just take out any power you see. This entire expression inside the logarithm is raised to a single power. All right, entire expression to a single power. And you can write this as an equivalent expression as well by basically kind of just pulling that power out in front and making it a factor, turning this into a product. So the power p, kind of pulls out. This is equal to p times the logarithm base b of just x now. The argument of the logarithm is just x instead of x to the p. Right, the p got pulled out front, and then x remained. Right. And again, vice versa, you can go in the other direction. If you see a number multiplied by a logarithm, you can take that number, that numerical factor, and put it inside as the power on the argument. Alright, so again, all these go in both directions. So these are the product, the quotient, and the power properties of logarithms. And like I said, I'll just write them out. We're not going to prove them or anything. And I'll just use them as I need them, alright, throughout these questions, throughout these examples. Alright, so back in the assignment, right, this first question, they're asking us to use the quotient property. They're telling us specifically what to use to write the logarithm as a difference of logarithms and simplify if possible. Alright, so we have the logarithm base 3 of 3/8. So I'll write that out. Alright, and I'll write it underneath the quotient property. So for example, using the quotient property, we have the log base 3 of 3/8, which I'm hoping you can clearly see as a fraction, right? A quotient. Right, a quotient or a fraction is the argument of the logarithm. Pardon me. And if that's the case, we can split it up. We can write it as an equivalent expression as a difference of logs. Right? The log of the numerator, the log base 3 of 3, minus the log of the denominator, log base 3, and again, all the same base throughout these properties, right? Log base 3 of 8. Great. And now, one of these you should know. Right? Remember, logarithms are exponents. When you're asked for the log base 3 of 3, remember this is just asking for, what exponent would I raise a base of 3 to get 3? Well, that would be 1, right? 3 to the first power is 3. So the log base 3 of 3 is 1. And then 8, 8 is not a nice power of 3, right? The powers of 3 are 3, then 9, then 27, then 81, and so on. So I'm just going to leave that as the log base 3 of 8. Okay, and this is all we're asked to enter here. Right, use the quotient property and then simplify any logarithms if you can, like the log base 3 of 3 here. Now we can also test this just to make sure that we believe this. I'm going to use a calculator and I'm going to enter these expressions into my calculator, and we'll see that they are indeed the same value. Alright, so I'll pull up a calculator here. I have a TI-84 simulator, TI-84 Plus. Again, you can use whatever calculator you wish. Now, on the surface, you have, remember this button here, LOG, that's logarithm base 10. Alright, that's not log base 3, so let's clear that. And then this LN button, LN, remember that's log base E, alright, the natural log. So again, if I want to put in the log base 3, I have to go into the math button here, and then down the math menu I go down to A where it says log base, and then I enter base 3. Alright, so the log base 3 of 3/8 is negative 0.89278926007. Right? So that means 3 raised to this power, this weird power here, 3 to this power should be 3/8. Alright, now let's enter the other expression we had. That was the initial expression. After using the quotient property and simplifying, we ended up with this expression that I put in a box. 1 minus the log base 3 of 8. And let's see, 1 minus the log base 3 of 8. And it should be the same value, and indeed it is. Okay, great. So getting rid of that. Looks like we did a good job here. And now let's go back. What I need to enter in the assignment is, I'm filling in some blanks. This first blank is just 1 minus, and then they already wrote the log base 3 for us. We just need to put the argument. Alright, and I said it was 1 minus the log base 3 of 8. And that should be good. Great. Alright, and then after every question, whether you got it right or wrong, there should be an answer explanation. I would highly recommend going over these. Now, if you got it right, go over it just to make sure you got it right for the right reasons. That you didn't just get lucky. Or maybe they do some sort of alternate method that you like better and can use for future questions. Now, if you got it wrong, definitely go over the answer explanations. Right, try to figure out where you went wrong, why you were wrong, and try to learn from your mistakes. Okay, next question. Alright, so this question's on the other properties, which I'm going to also write out. It says use basic properties of logarithms and the inverse properties of logarithms. Alright, so once again I'll write these out on a piece of paper for you, and we'll refer back to them when they're needed. Alright, so I'm just heading the page more properties. Alright, so let's call this, I had 1, 2, and 3 were the product property, quotient property, and power properties respectively. Number 4 here, I'll just write out, the log base b of 1 is 0. Remember, we're talking positive bases here. If you take a positive number and raise it to the 0 power, you're going to get 1. Right? So the logarithm base b of 1 is always 0. Right, and then something we saw with the log base 3 of 3, right, the log base b of b is always 1, right, because b to the first power will be b. Alright, and then there's those inverse properties. Right. Call these 6 and 7 here. And this has to do with the fact that logarithmic functions and exponential functions are inverses. So first one is where I compose, logs with exponentials. Put an exponential into a logarithm. So if you take the log base b of b to the x power. Okay. So again, this base here and this base on the exponent of x, these bases are the same. Then they'll just undo one another, the logarithm and the exponent here, and you'll be left with just x. Right. And hopefully, you could also apply that power property and pull the x out, and then you'd have x times the log base b of b, but the log base b of b is just 1, so you have x times 1 or just x at the end. And then the other inverse property is when I compose an exponential with a logarithmic function. So I put a logarithm into an exponent. So this is where I take b raised to the log base b of x. Right, so the exponent on the base of b here is a logarithm with that same base. Well, if these are right next to it, if there's no numbers times the log or nothing else but the log, then b to the log base b of x power will just be x as well. Alright, they undo one another in composition. Okay, and that should be enough to get through the questions from this assignment. Alright, so back here, so very simply, it says evaluate using the properties of logarithms. And look, this is 10 raised to the log base 10 of the square root of 5. So again, I'll write this out, refer to a certain property. Okay, so we have 10, and then the exponent on 10 is a log base 10. Right? Remember, when the logarithm has no base, it's just log, that's base 10, the common logarithm. So this is set up just like my last property here, the 7th property. 10 to the log base 10 of something, right? So this 10 and the log base 10, you can think of them undoing one another, and you're left with just the argument of the log. Right? So this will end up just being the square root of 5. And that's it. Very, very simple. Very, very simple. Now once again, if you don't believe it, right, let's check it out on a calculator. Alright, so let me pull that 84 emulator up. And I'll enter the first expression, which was 10 raised to, and then the log base 10 is right there, the log of the square root of 5. And we should get the square root of 5, which is 2 point something. Right, and then the final expression, right, should just be the square root of 5, same value. Alright. Okay. So it works out. This is true. This is correct. Alright, so back in the assignment, all I'm entering is the square root of 5. Very simple stuff, right? Because they didn't ask us to punch it in a calculator and round or anything like that, right? They just want it, if they don't say anything, just enter a simplified exact answer. Alright, and once again, please, read through your answer explanations. Alright, next question. Same thing, basic properties. This time we're given the log base 12 of 1. Right? The argument is 1. So back on my paper here. That's like property 4 I wrote up. Right, ignore that stuff. Log with any positive base or any non-zero base of 1 is always 0. Right, the log base 12 of 1 is 0 since 12 to the 0 power is 1. And again, I hope you understand or hope you remember from earlier videos how to transfer back and forth between logarithmic form and exponential form. And they mean the same thing, both forms. But yeah, the answer is just simply 0. Right? The log base 12 of 1 is 0. So again, pretty basic, pretty simple stuff there. Okay. Next question. Now we're back to the objective on using the product, quotient, and power properties. It says use the power property of logarithms. Now they're specifically telling us which one they want us to implement. Power property of logarithms to write the logarithm as a product and simplify if possible. So we're given the log base 4 of the square root of x. Now to use the power property here, we need to remember that anytime you see a root, square root, cube root, fourth root, etc., that can be expressed as a power. Right, and I'll write that out again. Right. So back to my paper. We're given the log base 4 of the square root of x. In order to be able to implement the power property, you need to write this as the log base 4 of, and then remember the square root of x is x to the 1/2 power. Right? And now I have something just like this. Right? I have the log with a certain base of some expression to a single power. This is some expression, and the only power that the entire argument is raised to the 1/2 power. So like in this power property I wrote earlier, we can take that power and just pull it out front. So the half comes out front, so we have 1/2 times the log base 4 of x. And sorry about the writing that you can see from underneath. Alright, but here we go. This is what we're asked to express. The log base 4 of x to the half, take that power out. Everything's raised to it. And again, it's got to be in the form where everything is raised to a single power. Pull that power out, and then we have half times the log base 4 of just x to the first. And that's all we're entering. And there's really nothing to simplify there because we don't know what x is, right? So I pull out a half, and then times the log base 4 of x, and there we go. Great. Alright, next question. So now we're back to that basic property, inverse property objective. And this is no different than the question earlier with 10 to the log of the square root of 5. We have 3 raised to a logarithm base 3. So those should undo each other, and I'll be left with the argument of the logarithm. 3 raised to the log base 3 of 6 would just be 6. So I'm not even going to write that one out. That one's real quick and easy. Very, very simple. Okay, next question. So very similar to one we saw earlier. 10 raised to a log base 10. Right, so 10 raised to an exponent, that's just a log base 10, so these will undo each other, and I'm left with the argument of the logarithm. 10 raised to the log of the square root of 3 is just the square root of 3. Very, very easy. Don't need to write that out. Very quick. Great, so that objective is done. Let's move on. Now the last objective, right, is just the product, quotient, and power rule questions. Alright, so here we're asked to use the product property, right? So we've been asked to use the quotient property, the power property. Here we're asked to use the product property of logarithms to write the logarithm as a sum of logarithms, right? Remember, in the product property, you write the log of a product as a sum of logarithms, and simplify if possible. So here I have the log base 10, right? Again, no base means base 10 of 1,000 times y, right? This is a product. So because I have the log of a product, I can, if I wish, re-express it as the sum of two logarithms. All base 10 though, right? All the same base. So this would be the log base 10 of the first factor, 1,000, plus the log base 10 of the second factor, which is just y. Now we can simplify one of these. You know, 1,000 is a nice power of 10, isn't it? So the log base 10 of 1,000, right? 10 to the third power is 1,000. So that's 3. All right, the log of 1,000 is 3, since 10 to the third power is 1,000. Plus, and then y is not, I don't know what number y is representing here, so I'm just going to leave that as the log of y. And this is what we'll enter right here. Okay. So back in the assignment, see I'm filling in the first part doesn't have a log, they're just 3. That was that log of 1,000, which is 3, plus the log of y, right? Just entering y as the argument for that second term. Great. Alright. And then this should be the final question. And once again, we're asked to use the quotient property, right, to rewrite. Now remember, the log of a quotient, the log of a fraction, can be rewritten as the difference of logarithms, the log of the numerator minus the log of the denominator. Alright, so here's the quotient property again. I had the log base 10 of a fraction, 10,000 divided by y. So if I want to, which I'm asked to do, I'm going to write this as the difference of two logarithms. The log base 10 of the numerator, right, of 10,000, minus the log base 10 of the denominator of this fraction of lowercase y there. And then simplify if we can. Once again, 10,000 is a nice power of 10. 10 to what power is 10,000? Well, that's the fourth power. Alright, so the log of 10,000 is 4, minus, and then the log of y I'm just going to keep as the log of y. And there we go. Right, that's what we're asked to enter in our answers. Right. So 4 minus the log of y. Great. All right, and that, again, please read through your answer explanations. And that should be it. Now, I highly recommend that you memorize all these properties. Right, going back to the page here, right, you got the product. Log of a product can be written as the sum of logarithms, and a sum of logarithms can be written as the log of a product. Quotient, the log of a fraction, can be written as the difference of logarithms, or the difference of logarithms can be written as the log of a fraction. Power, the log of a power, can be written as a product of that power times the log of the base, or a number times a log can be written as the log of a power. The log base b of 1 is always 0. The log base b of b is 1. The log base b of b to the x is just x, and b to the log base b of x is just x as well, these inverse properties. I would highly recommend memorizing these just to speed things up in the future. But if you don't memorize them, at least have them readily available when you're working on assignments. Alright, and that should be it for this version of this assignment. As I said at the top of the video, please know that the questions I saw here, might not be the same questions you see, but the objectives are the same. The types of questions should be similar. So I'm hoping that watching me go through these 8 questions here help you out in some way when you're working on the assignment yourself. And thank you very much for watching.